So in this question we're asked, what are the products of acid-catalyzed hydrolysis of N,N-diethylbenzamide? So we have first to draw that structure, figure out what that name is talking about, and knowing it's hydrolysis, we'll also have a water molecule involved, and since we're in acid conditions, we'll show that over the arrow, predict these products, and hopefully we'll all get to the same right answer. So let's take a look here. Our N,N-diethylbenzamide. I'm going to start with the benzene ring. So we're drawing our benzene ring. Again, the best we can do. Hopefully your drawings are better than mine. So originally we'll put the carbonyl there, and that carbonyl to nitrogen bond is what makes it an amide. And so we know here in this case we have a diethyl, so CH2, CH3, and another CH2, CH3, plus the water to make the hydrolysis occur. And we're going to do this in acid conditions, so we'll show just an acid catalyst. We could also talk about the specific acid if it's HCl or HBr or whatever strong acid we might use. And we'll also use heat. This requires some temperature, so that little delta under the reaction equation arrow shows that heat's involved, and now we can predict the products. So we're going to break this thing right at the amide bond. So there our amide will break, and that's a good indication of what we're likely to get. So just showing that one. All right, so back to our drawing. Now we have there's our benzene ring. So we'll get a carboxylic acid, and in this case it's going to be benzoic acid. Now if we were in base hydrolysis, then our acid would be deprotonated, but since this is acid hydrolysis, we have benzoic acid itself, plus we'll have the diethylamine. However, being in acid conditions, not only will we have our third hydrogen there to make it a neutral amine, we'll actually have a proton come and interact with that lone pair to make it an ammonium ion. So the products that we get here are benzoic acid, and we end up with diethyl ammonium. It's protonated because of the acid conditions, and again, if we said it was specifically hydrochloric acid used, then this would be diethyl ammonium chloride. So hopefully that gets you an idea. If it were base conditions, we'd have a neutral amine and a deprotonated acid. So if we do acidic conditions, we end up with an ion, a positively charged ion here. If we did basic conditions, we'd end up with a negatively charged benzoic acid anion, benzoate in this case, if we were to do the same reaction in base catalyzed hydrolysis instead of acid catalyzed hydrolysis. So either way, hopefully this was helpful, and it gives you a better understanding of how to use hydrolysis to break apart an amide into the carboxylic acid and amine or ammonium salt that would be produced.